The construction of modern housing is one of the most important priorities of state policy in Uzbekistan. Uzbekistan, along with many other countries, is designing a progressive policy for constructing comfortable and affordable residential houses within the state program of rural housing. Considering the depletion of natural energy resources and rising prices for their services and supply, there is a demand for the construction of energy-efficient residential buildings. Different national organizations have been actively involved in the implementation of the state program, which has been supported by a number of international organizations, including the United Nations Development Program.
The joint project of the State Committee for Architecture and Construction of Uzbekistan, the United Nations Development Program and the Global Environment Facility has revised the number of key building codes and standards. These new codes were implemented in 8 pilot social facilities buildings that were constructed and retrofitted with implementation of energy-efficient technical solutions. Given this experience, the project is now involved in design and construction of one pilot rural residential house in order to demonstrate possibilities to increase and promote its energy efficiency. Design of the country's first energy-efficient residential pilot rural house was made by our experts together with Taşıyıcı Design Organization.
Upon completing the design, the project started construction work by laying the first brick. Like any typical rural house, the construction involved laying the foundations, building the walls, laying the floors and constructing the roof. After this work began the stage of using energy-efficient materials, namely the installation of wall insulation with the use of insulation materials. The project carried out the indoor installation of walls. Wall insulation can also be added to the outside of a house, and for this purpose, wooden beams or a metal frame is fixed to the wall, the distance between the frame and the wall being wide enough for a heat-insulating mat. To ensure that the greatest level of thermal protection can be achieved, it is determined that the thickness of the thermal insulation mat for the walls should be 10 cm and 15 cm for the roof. Furthermore, the thermal insulation mat needs to fit closely between the wooden beams and the metal frame. We need to make sure there aren't any gaps when the insulation material is installed. To prevent condensation or moisture, which can lead to the growth of mold and mildew and their spreading into interior rooms, the insulating layer needs to be covered with a vapor-impermeable film with a foil side facing the room. This cover will also play the role of a heat-reflecting screen. The next step is to attach mounting rails for cladding the wall with plasterboard. Now the wall is insulated and ready for painting. Insulating material with coefficient of thermal conductivity of 0.03 to 0.04 and a thickness of 10 cm has the same thermal conductivity of a 2-meter thick brick wall. The use of modern plastic double-glazed windows is not only appreciated for its integrity, but it also provides good thermal insulation. The window will help keep the room at a comfortable temperature of 20 to 22 degrees with an ambient temperature of -10 to +40 degrees Celsius. Thermal insulation roofing is an important part of energy efficiency measures in a house. Its installation involves laying a plastic film that prevents moisture from going into the insulation layer. Next, the thermal insulation mat layer should be placed on the plastic film. In this case, the layer thickness should be 150 mm, and another layer of plastic film is placed on top of the mat. This prevents the ingress of moisture into the heat-insulating layer of the mat. Finally, a layer of clay straw composition gives the surface greater rigidity. This solution will improve the thermal conductivity of the roof, equaling that of a 6-meter thick concrete slab. The thermal insulation of the building's basement also requires the completion of a full cycle of insulation works. A distinctive feature of this home is the installation of solar photovoltaic and hot water heating systems. During the event of a power outage in the network, a solar PV system with a capacity of 200 watts is able to provide uninterrupted power to a home's lighting system in all rooms, while a solar water heating system will provide a family of 4 to 5 people with almost 400 liters of hot water each day. Also, the heating system and hot water supply systems using modern, efficient boilers have been introduced in the house, where a boiler with a connection to the solar water heating system is also used. Plastic pipes and aluminium radiators can be used for heating. An 8-section radiator will heat a 25 square meter room at a water temperature of 80 degrees. Prior to installing a radiator, it is very important to fix a heat reflective shield made of foil film onto the adjacent wall. This will help reflect most of the heat back into the room and will prevent the wall from being heated in vain while the room remains cold. The use of energy-saving light bulbs is another way to increase energy saving in a building. One energy-saving LED bulb saves 90% of electricity when compared to incandescent light bulbs. It is intended that a heat exchanger or ventilator should be used in the house. It is necessary to ensure there is air ventilation in the room with no heat loss in the winter. When airing the room in winter, cold air comes into the room through the open damper, while warm air goes out the room. This warm air transfers its heat to the incoming cold air, thereby warming it and warming the whole room in the process. Now all the main elements of the application of energy-efficient materials and technologies are completed. All that remains is to complete the painting and finishing touches. The State Committee for Architecture and Construction of the Republic of Uzbekistan, together with UNDP in Uzbekistan, has completed the construction of a first energy-efficient residential building within the framework of the state program for constructing rural houses. According to preliminary calculations, the expected savings of thermal energy in the house will be more than 50%. We hope that this experience will find its use in the construction of rural residential houses in our country within the framework of the state program. Thus, we will not only save energy resources, but also improve the comfortable living conditions of the rural population.